Okay, good afternoon, everyone. My name is Michel Botman. Welcome to this presentation of OTF Connect titled Using Math Moment to Multiply Math Skills. And today's episode is called Math Moment Through Proportional Relationships with Carl Pearce and John Orr. So as we were mentioning, this is already the episode 6 in a series of 10. And as we were mentioning as well, and John did a very good exercise a few minutes ago, and I'm starting to noticing the same names and familiar faces. So I just want to thank you all for your participation in our OTF Connects Math webinars. And I must tell you that we truly appreciate your participation, since without all of you, we could not sustain this program. So thanks a lot. Let me quickly jump my slides ahead. Sorry a second. Here we go. I just want to jump to the land acknowledgement that OTF is asking us to read. We acknowledge that we are all gathered in the territories of various indigenous people, and we further recognize their stewardships of these lands in which we live, learn, work, and play. And so I just want to thank you all for being with us again this afternoon. And we are also obviously delighted to have Carl Pearce and John Orr with us for this episode. And since most of you are returning participants, I'm not going to read the entire bios of Kyle and John. I can just, as I do, invite you to visit their websites. They each have 2 blogs. Kyle has one that is called tapintoteenminds.com, and the other one is called Math is Visual, and it's actually very visual. The logos are really, really cool. And John, who is the second presenter, or the first or the second, I don't know. Actually, John starts, so I should say John is the first. And and John also has 2 really cool websites. His blogs are called MrOrIsAgeek.com, and the second one is called MathBeforeBed.com. And if you want to follow them and access the resources that they have, I just invite you to go and visit their blogs. So that's it. We have 40 participants. I think we're going to grab a few more as we go along. And I'm going to now give it to Carl and John, and go ahead, guys.
Awesome stuff. Thanks so much, Michel, for always that great intro for us. And like we start most of our webinar sessions, or all of our sessions for this one, get yourself in the chat. Most of you have done that. There's that chat is filling up, and let us know where you're coming from. Let us know your role. And also, again, like I said right at the beginning at 4 o'clock, let us know how many sessions you've been to. This is episode 6 of 10, and we've had a great time for the first 5, and we're really looking forward to working on this one with you, which is all about proportional reasoning, right, Kyle?
It sure is. We are super excited. Last time, and you'll see in the back here, as Michel was saying at the beginning, and John was mentioning, we're tinkering with all kinds of tech toys right now. But we played with this hot chocolate task, and that was actually an example of proportional reasoning, and a proportional relationship could be revealed, as we saw in the last session. So today we are going to go ahead and we're going to jump in here right into some slides. John, do you mind going ahead and pinning me for a bit here anyway?
I'm going to, but I'm going to ask Michel to stop sharing his screen, and then that should, I'm going to do a pin here on Kyle, and that should put him up front and center for all of you.
Go. Awesome, awesome stuff. So we're not going to waste any time here. As Michel said, I'm Kyle Pearce. We got John there. Hey, John. We are super excited to keep diving through. And again, we are hoping to keep on this mission. And as we've done in all of these episodes, at the beginning, we like to share a little bit about what you're going to get. This is more now probably a little repetitive for some of you who have been with us this whole way through. But for those who are new here, John, what's one of the things that we're going to try to do? Because we try to do it as often as possible in our classrooms.
Yeah, so this is the one that we've pinned to every one of our sessions, is that we hope that while you're here with us, and if this is your first one, you're seeing this for sure for the first time, but we want to engage our students. So we want to spark curiosity. We're going to do that today with a task like we've done in every one of our sessions, and we want to kind of get the ball rolling with some curiosity. And we're going to use something called the curiosity path that we've used in every one of our sessions too. So we're hoping that you get to spark your curiosity so that you can spark your students' curiosity. Kyle, what else are we hoping to do in this session?
Awesome. Committing one of our rules we try not to do is not to release what math concept we're going to actually be diving into with our students.
Breaking it.
We're breaking that rule here. We are all educators. So I think from an education standpoint, from a content knowledge standpoint, we want to be upfront with you and clear about where we're going to be going today. And hopefully that'll help you as we're going through the task to start thinking of, why we started where we started and where we're going. And maybe it might even help you with some of the ideas on how you might solve today's task. Because again, we are going to dive into the math as we have in all of these sessions. We're going to push you to get doing some math with us. And John, what's the last one, which is probably the most important for this whole series?
Yeah, and it's one that we've definitely tried to make very clear in this whole series, is that we are here to, obviously get better at knowing the math ourselves, so that we can help our students, but we want to repair and strengthen that relationship we have, because if we can do that for ourselves, then you're better equipped to help your students do that. So that's one of the big things that we want you to take away here today. And like all of our kind of what you'll get, we're going to bring those back at the end, and we put them up front so that what's coming your way, and we want you to hold us accountable as we go through, making sure that we hit these things for you so that you can learn as best as you can. Cal?
Awesome stuff. So we are going to be doing this through our 3-part framework that we reference all the time. There's a link up on the screen if you've never read up on it. It's a very, very long read, but in a good way. It really helps to break down the process that we use to kind of develop these tasks. So just as a quick recap, last time we explored the hot chocolate task, right? We had you make estimates, and we really were we started with a very simple problem, how many scoops in 3 glasses? And then we extended that, we rode that context, and we tried to get to how many glasses could we make if there were only 55 scoops? So you gave us some estimates, we jotted them down, we talked about them, and we had you share out your thinking with us. And we went through like kind of a big progression of models and strategies. John, what do you remember from some of these strategies that we saw? What were people sharing? How are they going about solving this problem in a conceptual way?
In particular, we saw lots of like a variety of strategies. Like we had people draw pictures of like a number line. We saw people there was a lot of boxes, I remember, Kyle, boxes, and then there was like things in the boxes to show how many scoops were going to be in each glass. There was like these visual models, and then we kind of modeled that with a number line. But there were some people just solving that with division, right, or solving it like how many, and then just some rates coming out. It's always great to see all the different solutions, and that is one of the big things we pulled together last episode, was seeing all those, and then how do they fit together? How does that, say, division solution mimic what's happening on the double number line, and how did that mimic what was happening in the boxes? I really appreciate that the folks here in these sessions are showing those solutions so that we can put them all together.
Absolutely. We had some people, making connections between this double number line. And I don't know if there was anyone with us last week who actually used a double number line in their own learning experience. And John and I, we're both like that. We were in that camp that we had no idea, but that this double number line actually is kind of like on our journey towards a table. And in this case, a ratio table. And we explored this idea that, wow, a proportion, this guy right up here is just like it's just a part of that table, right? And we can actually solve proportions using conceptual understanding instead of just rules and procedures that we're mimicking. So today we're hoping to keep this going, and we are going to get you participating. So John, have a look in the chat here. I want to make sure, is everybody with us? It's been a long day.
Are you guys with us?
Digital learning for everyone. How's it going in the chat here?
Give us a, I'm here and I'm ready.
You here? Are we
chat.
ready to go?
Sometimes this is what I do with my students when we're teaching remotely. Sometimes it's like, I've been talking for a while, and then all of a sudden I'm not sure if anybody is here. And actually a couple times I had been like kicked off the internet, and I had been talking probably for a couple minutes. But I always just like, are you guys with me? Are you ready? Give me an I'm ready in the chat. And it looks like, Kyle, we are all ready to go for today's episode.
Everybody is ready. That is awesome. Awesome. So we are going to get started here. We are going to get you to wear those two hats like we have in each and every episode. We are going to have you thinking of this like a student would. And we'd like you, if you're in the classroom, if you're actually teaching currently and you have a position and you're in the classroom with students and you just finished your teaching day, I want you to pick a student in your class. And it might be a student, maybe it's a marker student, maybe it's a student that, has struggled in the past, or maybe it's a student that is quick to come up with answers and not model their thinking. I want you to kind of like emulate that student and try to anticipate what that student might do. So, if you have that student in your mind, you're going to kind of try to be that student a little bit to engage as that student would. And then at the same time, we're going to have you kind of like step outside that and kind of look at it from the teacher perspective and try to analyze as we're going through, like, what moves are we trying to use and where are we trying to go with this mathematically? Now, with our students, we're not asking them to do that. We just want them to truly engage in the task by sharing anything and everything that they notice and wonder. So what do you say, John? Do you think we're ready to do this?
I think we're ready. We're diving right in. And if you've been here before, you know what to do. You're going to put the notices and wonders in the chat as they come up. Last time we had held back sometimes on when we put estimates in the chat. We'd say like, hold back. Let's do a chat explosion. We don't want to do that here. In this particular case, we want all those notices and wonders to funnel in as you think of them. Okay, so get ready, get your typing fingers going, or maybe your jazz hands. Wait, all you camera people, show me your jazz hands. Let's go. Let's get those typing fingers ready. Here we go. Awesome. Let's get going and ready, Kyle.
Here we go. I'll play it a couple times for you, so keep them flowing. Here we go.
I see Kyle on the screen in front of the video. Here they come. Michelle's first in.
Okay, all right. All right. Those noticing and wonders, those notices and wonders should be coming along nicely. I'll play it again for you.
One more time, Kyle.
Yeah, feel free to keep them coming. John, if you want to start making a few of those audible, let us know what's coming up in the chat.
As you guys type, this one is a good one to not shy away from. I think we might have talked about sometimes, Kyle, our webinars blend together. We've done a good chunk of them over the last month or so. And the one I want to bring up here is like when a kid says like, what is going on? Like, why are we doing this? And if you've been planning this lesson and getting it ready and you're excited for this lesson to go, and when a kid says that, you get like, there's a natural like, but you know what, that question, you want that question because that question is great to write up on the board or bring out on the screen, depending on how you're teaching this. Because that question is like, you get to fuel the fire later on that question. Write it up. Why? Like, that's a great question. What does this have to do with math class? We want that there. So at the end of the lesson, once you've brought the math forward, if you think back to the previous sessions and how we asked you to notice and wonder and think about all the math we dissected, all the math we had discussed and seen those solutions, then you can go back to the kid and go, well, why did we do this? Do you get it? And they're like, They answer it themselves. So it's a great one. And I know that some people are like, I'm not gonna highlight that one. Do it. Highlight that one, because it basically sets your point for you by the end. You've just used that to say, this is why we learn this way in math class. So that was one I saw, Kyle. There's got some notices here, like how many names are going to go in there. And I wonder, there's a vote going on here. Seems like a murder mystery maybe, and it was have to vote. There's like, maybe this is a draw. I'm winning something. Tanya says, is Sonia a student? Ness is like selecting a choice, one of many to be filled out. There's lots good notices, lots of wonders here happening. He's typing them up.
I love it. Lots of notices, lots of wonders. Awesome. Awesome. Any other thoughts there, John? Any others you're seeing?
What do we got? If I just scroll here, what's the chance to pick a name? Like what's the probability that one person gets picked? I added the word probability though. I saw that. How many pieces of paper are there, Kyle? That's a wonder. What do you got to wonder here? Who's getting voted off the island? What's it for? Is this a contest? Why is the label covered?
Love it. Lots of people starting
to
notice.
How many people are there, Kyle? How many people are going to be there?
People. I love it. So we've got so many different notices and wonders here. And again, as we've done in the past, it's almost like the part I'm liking about these sessions, John, and I know you and I have talked about it, is like a lot of people have been with us each of the sessions, which is great. There's always going to be some new friends. So we're trying to kind of like make sure we don't leave out some of the details, but you'll notice that in the first session, we spent a lot of time on the notice and wonder.
Yeah.
Right. But now we're like into episode 6 and we're spending less time on the notice and wonder. And as you do this with your students in your class, you want to make sure that their voice is heard. By now, people are feeling like comfortable. They're feeling like it's a non-threatening environment, and we don't have to spend as much time there. Okay. Now that's not permission for us to just go back to the way we used to do things, but just so that people who are wondering, like, how much time can I actually commit to this? We can do this. And we can start to be a little bit more efficient with it so that we can maximize our time on the conceptual piece of the math. So I just wanted to make sure that that is clear. John, we had some good noticing, good wondering. Is there anything here that you see that we might be able to like help them with? Like, what are some things that we can help them with in terms of confirming notices or answering some wonders?
So this is also good. Sometimes I like to hold back on everything until the end and then go back and answer them after we've brought things forward. Because usually I want their thinking to come out, but you know, we do want to narrow down what we're working on here, and you can kind of bring some of these forward to answer right away. Like for example, Kyle, I think we could probably answer or bring up like an estimate of like how many people voted, right? It's like, let's think about like the number of votes, because that's what's happening right here. We've got a vote happening right here. We got a certain amount of names are going to go down on those papers. We could talk about that, Kyle. We could let them in a little bit more. And what we're trying to do is like, instead of, you know, math class normally is like, let's just open the door and we just fill them full of knowledge, all math right away. And what we're doing is we're like slowly creaking the door open and slowly getting our students into the math task. Okay, it's one little step at a time.
I love it. And actually sometimes too, like this is from a class I was in recently. I was with students and they came up with some of these. Sometimes they're asking like, is it a vote? Is it something else? Like maybe it's a draw. Like it could be any of those things. But as John mentioned, in this case, we're actually going to be doing a vote. And I want to set the context for you a little bit, because actually Sonia is a student and she is running for a position. Now, for you teachers out there, all of us are teachers here, I'll let you know that I changed the context a little bit to sort of match the class that I'm in. So for example, if it's a grade 8 class that I'm doing this with, I'll talk about like valedictorian or something, grade 8 graduation. If it's a grade 9 class, I might talk about like the student parliament they're running for student parliament or something along those lines. So you get to kind of control that context and sort of make it fit your context and your students' context as much as possible, make it as relevant to them as possible. And then from there, we actually get to like kind of hone in on some of these questions that you folks brought up and some of these students brought up. So for example, like some people are saying, how many people or how many pieces of paper are there? These are some of the things that I'm actually going to ask you now. I'm going to let you know that actually, if I let you watch this video here, there's two things that are going on here. First of all, Sonia is one of the people on the ballot, and Eli is the other. And there's actually only two people running for student parliament this year. So as you'll see here, this particular stack of paper, as you'll watch this little video, that is all of the votes for this particular election. And my friends, that is something that I'd actually like you to think about first. It was hard to see who had the most votes. I think you'll know. But something that I think you can do right now is you might be able to set yourself up for a nice estimate. So that's what we're going to have you do right now, because you saw that this pile of paper right there, that represents all votes.
All the votes.
Every single one of them. So I'm going to zoom in on it a little bit here for you. And we're going to have you set yourself a nice range. We want you to think about that low, a high estimate, like numbers that you know are kind of like too low or too high, and set yourself a nice little range. And then we'll have you share out your best estimate.
Right. Let's do what I discussed a little bit earlier. When we share out our estimate, so right now you're trying to come up with a too low, too high. Let's hold back on putting them in the chat for now. Well, we're gonna have a chat explosion. So right now you're imagining you're too low, you're too high. We'll get you to do that on your own. But then the idea is you're going to settle on what is your very best guess for how many people have voted. So you got your two highs and your two lows. Usually when I'm doing this with my class, we're having them share out loud or writing maybe the two highs or two lows in the chat. But what we're going to do is save a little bit of time here. We're going to ask you to put only your best guess in the chat. And then what I like to do also is the best guess in the chat can also funnel in or section off like what's the too low and too high of the group. And I like to kind of look at that interval. And we're going to do that in a moment. So get ready to hit enter. So you can type it, but don't hit enter yet. We'll hit enter all at the same time, and then we'll have a chat explosion. Okay, you guys ready? How many people voted? Your best guess coming your way in 3, 2, 1, go.
Look at them coming out.
There's lots, Kyle. I'm scanning. I'm seeing a low numbers of, the lowest I thought was a 40 somewhere. So these are your best guesses happening right now. And I'm going to argue, if you put a range in, go ahead and put another number in there, put an actual value in, give us, you gotta like pin it. You've got to get your guts out, right? You've got to like, let's say I got to have guts. That's what we do in our classes. Like, let me see how much guts you got, or how many, where's your bravery? That's what I usually try to say to my students. How brave can you get with your answer? And how close can you get to like, what's appropriate here? So we'll ask you to kind of make sure you can do that. Highest number so far I've seen is a 200, Kyle.
200 is too high, or is that best guess now?
Well, these ones were all best guesses.
Guesses, sorry.
But the highest best guess I'm seeing is 200. The lowest best guess I'm seeing is 40. That's a huge range, right? Like we've got between 40 and 200 for all of you folks ranging in there.
All right. I'm loving it. That's a big range. John, do you have any that are like, do you feel like any clusters forming here? Give me a few more.
So you're drawing a number line. I see now. I was looking at the chat, but I'm seeing a lot of 50s.
50s.
I'm seeing 65 a few times.
65.
I'm seeing
spatial
60.
reasoning is not working very well if I start comparing to my 200.
Yeah, don't look at that 200, everybody. I'm seeing a 75.
75.
I'm seeing a 70, 65, 50. Best guess is a 75. I see a 250 now, Kyle. I now seeing a 250. I'm seeing 150. Came in right now, just a moment ago. There we go. That kind of sums up the most of the guesses, Kyle.
We've got a nice range. So again, like highlighting this idea that like, from here to here feels pretty good for a lot of people, but I'm noticing, like, at least based on what you're saying, like we'd have to analyze the chat a little further to see where that real cluster is. But I feel like that cluster is
for sure. It's right
sort
there,
of like around here, right? So we, for those who are teaching stats or data management, like box and whisker plots and stuff, like you can sort of see how even just this exercise can be helpful for kind of collecting this data and then being able to represent it on a box and whisker plot, which I think is kind of cool and kind of helps you see where that central tendency is, right? So I'm feeling pretty good in this range here. That is awesome. You can update your estimates as we always allow you to do. So we are going to go ahead and we're going to give you a little bit more information. John, like, do you think that's worth it here, that we give them a little more to work with?
All right. I think so. Let's up the ante a little bit.
All right, let's go ahead. I do want to, I'm going to let you have another look at this. Okay. So in the chat, just freely, don't wait on a waterfall. I'm just going to show you what this looks like once they're all in there. So they're kind of like not all packed in together. You can kind of get a different perspective. I don't know if that helps or hurts. Like if you said 40, does that feel good? Or if you said like 250, does that feel good? Or you want to adjust that? Feel free to get that in the chat. Let's see if just visually, John, as you're scanning it, like, are people getting tighter? Is that estimate getting tighter?
They're starting to trickle in. Yeah, I'm seeing a hovering around a high 50s. So we got a 58 and a 50 and a 60, a couple 60s. 70s. It's kind of still in that range, Kyle, between 50 and 70, I would say.
So it's almost like reiterating that range, which is kind of nice. So it kind of gives you, okay. All right. So here's what we're going to do, because we want to start like getting to the sense making. We got your like brain thinking. Everybody in the room should be clear on the context, right? So again, think of this huge hurdle that we've overcome. We've overcome understanding the problem. Right? My daughter, if I show you the whiteboard over here, it's word problems she was working on virtually today. She came down, I had to step out of a meeting, and basically we had to work together so she understood what the problem was all about. We are over that hurdle. That is so helpful. And that's one of the reasons why we like doing this sort of engaging task. Now, what I think we're going to do, John, why don't we just cut to the chase here? Why don't we just count these out so that we can put this problem to rest. All right.
So when we count them out, let's do something a little sneaky though.
Yeah. Like start counting like 1, 2 for Sonia, 3, 4, 5, 6, 7. Oh man, I'm going to get confused.
3, 4, 5.
Shoot.
You mixed them up.
All right. Now in the chat though, like have a look. At least, does anyone know who won this vote? Like, is anyone confident without us even counting? Like, how do you feel about who won this election, this vote?
Clearly everyone is this is not a trick, Kyle. This is not a trick. Everyone's like Sonia, of course. And this is when you pose that question to your students on this problem, they're like, of course, Mr. Or of course, Mr. Pearce. Sonia has won clear and fair and square here. I thought that was a problem. No, remember, this is not the question we're working on. We're not working on who wins the vote. We are working on how many people voted.
Now, here's my question then, John. I want to up the ante a little bit. I want everybody to look at these two piles. We know that Sonia won. Fantastic. Let's try to see if we can help with our estimates a little bit. I want you to look at Sonia's pile and Eli's pile. And if you think back to episode, was it 3? Maybe it was episode 3 or 2, where we talked about multiplicative thinking. And I want to challenge you to try to create a multiplicative comparison between these two piles. Basically meaning, like, how many times bigger is Sonia's pile than Eli's pile? And then once you've done that, I want you to then try to say how big Eli's pile is compared to Sonia's pile.
Okay.
John, you might have to reiterate that because there's big thinking there. Reiterate for the group.
So actually, I'm going to use an example here. Joanne has done that before you even talked about it.
Whoa.
And Joanne had said, it looks like a 2-to-1. She used that phrase, 2-to-1. So that is out there. Like, and then Kyle's asking you to kind of do that, but kind of say how many times bigger Sonia's pile is compared to Eli's, but also then wrap your head around the other way. What's the multiplier between Eli's and Sonia's? Like that's hard to think about sometimes. We usually try to go bigger to smaller, but I'm seeing like Eli is 1.5 times times 1.5 of Sonia's. I got tongue tied there. Joanne is again saying Sonia has twice as many votes as Eli, so she said it in words that time. We've got Michelle saying 1.7 times Eli's. Very precise. Annabelle's even more precise here, Kyle, to the hundredths. 1.75 to 1. Here's another one. Are
these all as ratios? Because I can't really see.
Here's another one. Ness says something interesting. Everybody has written 60 to 30. 60 to 30. She got some precise numbers in there. Nice. And then we've got Sonia's pile is 0.3 times bigger. That's somebody else's. Sonia's is 1.5 times as Eli's. There's a lot of 1.5 Kyle's, a lot of 2-to-1s as well.
Super cool. Now I'm looking at this. I'm just jotting down a few of these, and any one of these could be right. They could all be wrong. We don't know. That's not our main concern here. But I'm going to zoom in on one for a second, like one that I think is pretty low floor for us to work with. I'm going to focus on this one. If Sonia's is 2 times as big as Eli's.
Kyle, I'm wondering, can you blow that up a little bit?
I sure can.
Or put it on the background there. It's hard to see those numbers on my end anyway.
Yeah. Can you see that?
That's better.
A little better. So I'm wondering if that's the case, that Sonia's is 2 times as big as Eli's. I'm wondering, how would you describe Eli's pile then? How would you describe Eli's pile? And I'm wondering if anyone in the chat could help us out with that there.
Yeah, how would you describe Eli's compared to Sonia's? Like KD's right away, I think people are like Afeza says half as big.
1/2.
Half the size of Sonia's.
I love that. So it's
a lot
like
of halves.
Sonia's is 2 times Eli's.
And I just want to, Kyle is asking very strategic questions here, and he's got a purpose, and I don't want everyone to think it's like, man, he's really dragging this out. But there is,
although I like to do that too.
There's definitely a purpose into the language. So remember when we started this task, like our other task, you're wearing 2 hats. You're being the student by answering these questions, but you're thinking about, why is Kyle asking that question? What is it like? What's going to be the point of asking 2 to 1 and then like comparing it a 1/2 to 1? So there's some very subtle kind of questions happening in here. We hope you pick up on some of them.
Awesome. And I'm going to now focus in on this one for a second. I got to move my head out of the way for it. If we look at this one here, I saw one in the chat, and I'm going to pick it on purpose because the fraction is a little different. We could take these and convert them to fractions as well. But I saw someone in the chat say Sonia's was, I think they said Sonia's was, or no, Eli's was 2/3.
I did see that as well.
which is the same as saying Eli's is 2/3 times Sonia's pile. So it's 2/3 of Sonia's pile. My question is, in this case, this might not be your estimate. I'm not just asking the person who shared this. I'm asking you to think about it. If that is true to you, you say Eli's looks to be 2/3 of Sonia's pile. And if I go back and actually look at the piles for a second, and I look at this and say, like, this is 2/3 of the way up Sonia's pile. My question then becomes, what's Sonia's pile compared to Eli's pile? What would that be? Interesting. What would that be? Anyone willing to share here? And John, help us out. What would that be?
I'm seeing this one whole to 2/3. Marcus has said. Janice has 3/2. Sonia's 1 1/3. Joanne's also 3/2.
Awesome. So I'm going to have a look at this pile here, and I want to make sure, like, if we're looking at these piles for a second, and if I was to take this Eli's, and if I said that this was 2/3 of Sonia's pile, I'm going to go ahead and actually draw this out for a second. I'm going to draw it out right here. Okay, Sonia's pile, I'm going to kind of swap them a little bit to keep them together, but here's Eli's pile. I'm saying that Eli's pile is 2/3 of Sonia's pile. So that means Sonia's pile is the whole. So that's Sonia's pile. I'm telling you that Eli's is 2/3 of Sonia's pile. Now, when I come over here and I start comparing and I go, wait a second, now Eli's pile is the whole. All right, and if I look at that and I kind of compare that a second and I go, wait a second, now this is Eli's pile. And I know that Sonia's pile is right next to it. There's Sonia's pile. If this is the whole, what would I call Sonia's pile? I'm wondering here. Do a little zoom in there. And I see a few people are saying 3 halves.
Marcus is saying whole plus more.
Whole plus more. Yes.
Whole plus more.
And I love that. So Marcus, you're probably thinking like your student too, right? Like a student would say that. And I'm going to go, absolutely. I'm wondering how much more.
Max says 1.5.
Like 1.5. I hear some people saying 1 1/3. Let's try to like prove this for a second. So if this is one whole, I'm going to just draw a dotted line. I can see that it's definitely 1 and some, like we heard in the chat. It's 1 and some for sure. Now, my wonder is, like, how big is this compared to that whole? Anyone want to be brave? I'm going to get nice and close here so that you can even see the blocks. It's not perfect, but you might get a good sense of it here. It's a half, right? This would be a half. So I could say that Sonia's is like 1 1/2 times. But something else I want to make sure that we see here, like if we look at this thing, we could say, wait a second, if I chop this up here.
Now, Kyle, you should make this clear because there's a lot of 1 1/3 floating around in the chat. And I think that's common to think because you're thinking, because this actually
kind of thinking over here, right?
Yeah,
like you got this in your mind.
Like, wait a minute, I got thirds over there. And if I come over here, I'm like, what? But I still see a third.
Yeah, it's like trying to get yourself to unsee the other perspective is so difficult. And yet when I look at this and if I say that this is the whole, now I can say that this is definitely going to be 1 whole plus a half. Or I could say, well, wait a second, let's break the whole into halves. I could say there's 2 halves in a whole. Well, here there's 1, 2, 3 halves. So I could say 1 1/2 or 3 half times. So these are equivalent. And just think of, to me anyway, think of the power we're not even dealing with fractions right now today. That wasn't like our intended focus, but think of how many students are converting back and forth between mixed and improper and proper and mixed fractions without really understanding the why behind it. And a little later, I hope in one of our future episodes, we'll be able to kind of talk about like division of fractions relies on this thinking. The entire thing relies on this thinking. So hopefully we'll have some time to go there. But I'm loving all these estimates, John. These look great. We've got comparative thinking here, this multiplicative thinking, which is all the backbone of proportional reasoning and proportional relationships. What do you say we keep going a little bit further? What do you say we give them a little more information and let them dive into this problem and actually get into a productive struggle here?
Let's do it.
All right, here we go. We are going to go ahead and we are going to keep this thing rolling along. You folks, I'm hoping you keep this comparison, because that comparison you just estimated, we're going to go back later and see whether your comparison was reasonable. Is it exact? Is it a little bit off? What is it? But I'm going to tell you something. After we counted this thing out, I can tell you this, that Sonia had 60% of the total votes. Okay. Is everybody cool with that?
Got it. 60%. Yep.
So Eli had the rest, because remember, there was only 2 people in this vote, only 2. And I'm actually like, I was nice enough for you. I went and I actually counted out the difference in votes, like how many more votes that Sonia got than Eli. And I did it because Sonia actually wanted to rub it into Eli. So I just wanted her to know, hey, this is how many you won by. Just kidding. I would never do that. But we do know that those 2 piles on the right have the same number of votes, but Sonia had 24 additional votes. So Sonia had her 60% of the votes. Eli had the rest. And the question I have, we know that she won by 24 votes. My question is, how many votes did Sonia get? And how many votes did Eli get? And the big question that we were asking earlier is, how many people voted? So we want a full breakdown. We're going to open up a knowledge hook room for you for snapshots. We are going to turn our cameras off for a few minutes. We want you to engage in this. It's like I say to all the students when I go into classes and I do a lesson, engaging in this task is where you get the most value. So definitely engage. We're looking for that student-focused strategy model. And remember, we don't actually want to hear the answer in the chat. We're not concerned about the answer right now. We're interested in strategies and trying to, how are you going to try to convince us of your strategy as we go?
I like how Joanne just got her whiteboard out and ready to go. And remember that the process here, Kyle reiterated, we're looking for strategies. Like if you've been with us before, you know this process that we're going to be comparing some strategies. We're going to be kind of connecting some of your diagrams and your thinking together, but we need to see that too. So if you've been with us before, you know that you're going to do this work on a piece of paper, or you're going to do this on a whiteboard like Joanne is doing, or you're going to you can do this digitally any way you like, but you're going to need to take a picture of it. So you can use your device to take a picture of it, and then you're going to go to that link. Now, Kyle, again, I'm not, maybe it's just because I'm in a certain view here, but if I go to speaker view, I guess I can see it. I'll put the link in the chat so that you can see it a little bit more clearly. But once you have your picture, you're going to go to joinkh.com. It's going to ask you for a code. And with that code, you type it in. And then I think you put your name in, you're gonna, you choose guest. There's like a little button at the top, just pick guest. And then you put your name in, you choose a little robot, and then it will give you a button. You just click the button and it will upload your picture that way. Okay, so we're gonna give you some time. We're gonna turn off our cameras and our mic. We're gonna give you a couple minutes to do that because we want you to think, use your thinking. All right, we'll see you back in a couple.
Absolutely. And also to address in the chat, a few people were stating some restrictions that they might have. Remember, we are not using a calculator here. How are you going to model it? There's got to be a way, is what I always say to students. Like, how can you challenge yourself? Think of some of the models that we've used over these last few sessions. Might they be helpful to you? And we will check in with you in a couple minutes' time. All right, I'm starting to see some solutions coming in here. This is a challenging problem, but something that
I'm
I
excited.
found, and I don't know about your experience, John, if you've had the opportunity to use this this particular task. I've gone into a grade 10 classroom, and I had a lot, and it was a grade 10 academic classroom, and they had just finished a unit on solving systems of equations. And
Right.
every student attempted to solve this problem using systems of equations, but they couldn't get an equation together. They weren't sure like what to do, but they knew the steps to solve systems of equations. I wonder if we'll be able to find some interesting models here today in order to do this a little more conceptually.
Right. Yeah, sometimes the curse of the unit you're sitting in sometimes can hurt you or help you. You know, sometimes you see a math problem and you're in the linear systems unit and you're like, yeah, I'm going to solve that with linear systems, where maybe you could have solved this more elegantly or clever, a more clever strategy than, say, setting up a system in this case. That's sometimes the downside of, you know, always working within a unit and saying, hey, only the problems presented in this unit can be solved using this technique. So that's a reason why you and I have kind of moved away from unit-based and solely been teaching through tasks like this one to kind of bring out natural problem-solving skills instead of students trying to fit solutions because they think they're in the proportions unit, or they think they're in the integers unit, or they think they're in the algebra unit.
I love it. I love it. What I'd
All
like
right,
to
let's
do,
see
I see some great solutions coming in. What I'm going to do is I'm going to actually ask, and I'm going to go ahead and create a couple new slides here so I could just paste some of these images on here. I see this image here, and I'm going to paste it right onto my screen, upside down, of course. Let's go ahead and flip that around here. And what I found, what I want you to do is have a look at this particular
Interesting.
solution.
That kind of looks like what you were modeling.
I'm wondering, yeah, like using that model or leveraging, what I'd like everybody to do is to have a look at this. And then I'd like you to think about what might this person have done in order to solve this? Like what I'm seeing stuff here, but I would like you to try to interpret a little bit on what's going on here. If you can, if you'd like, and share some of your thoughts in the chat. Do you see your thinking in this? Do you see something else here? Is there anything you change? What's going on here? And then we might check out a couple others as well. All right, what are we seeing in the chat here? I see it says like, is this like a part whole model? And I would argue it's kind of like a part, and then the whole is like putting them together.
Right.
So yes, I would say yes, this is like the two parts and the whole would be like adding them all up together. I'm wondering why, like, is it valid to have it split up this way? Because, you know, here I could argue that there was maybe some assumptions made, but maybe somebody else could like help us understand, like, why does partitioning the piles the way we did? And actually, dare I go back to my document camera here and reference this model that we spent a little bit of time on. I don't know if you notice any differences there between that model, this model, and this one right here, but I'm seeing some similarities there. I'm wondering, why does partitioning it this way actually work in this particular scenario? Is anybody able to help us with that? What do you think?
Does anybody want to turn their microphone on and be brave here with us?
Oh, I love it. If bravery
do
is
do a hand raise. You could do a hand raise. Oh wait, can you do a hand raise here, Kyle?
You can
somehow.
somehow.
I forgot. I forgot how to do that.
There's so many platforms we're using these days. It's very difficult.
Oh, it's in the, maybe not. Hang on. I just had my participants window open.
Yeah, at the bottom of the participant.
If you go to the participants window, you should be able to click.
You don't see it because you're a host.
Oh, that's right. That's right. You told us that last time, Michelle. We forgot. You should be able to do a hand and raise, and that should pop you to the top. But you gotta be brave. I know that's tough. You're like, oh my gosh, there's a good chunk of people here. I've got to say it in front of everyone. But
and I'm
hey,
loving,
we're all friends here. We're all friends, right?
I'm loving a ton of people in the chat are sharing now. Like, for example, Michelle says that 40% is 2/3 of 60%. 40% is 2/3 of 60%. And if you haven't made this connection yet, this might be something in your class you have to have students share, is that the whole vote is 100% of the votes, right? So we have 100% of the votes, 60% went to Sonia, 40% have gone to Eli based on a little bit of reasoning here. So we know that it's a 60-40 split. So now I just want to double check in this model to make sure this makes sense. If this represents 100% of the votes, then I have 20%, 40%, 60%, 80%, 100% of the votes. And
nice
I
model.
know I've accounted for the entire vote. So our original prediction, our original share that we had here, this model that we did some estimating with, whether you realize it or not, actually is accurate. We know that this is the relationship between those two piles. So that to me is like a huge, cool win for sure. Now, the next part here though is like, how do we confirm or deny these 24s?
Where are
like,
these
can anybody help
24s
us
coming
with that?
from?
I'm trying to figure this out.
Love the pictures and numbers. Missing the words. This is what Faye is saying. So does this example give us an 80% assessment?
I wonder if you want to elaborate on that.
I think she's trying to say, I think when she says assessment, my guess, maybe Faye can fill us in on that, but she's say if she had to mark that, she would give it an 80 because it has a picture and a solution, but it doesn't really explain what the thinking is behind the picture, which is what we're asking for right now too. So Joanne's got her hand up.
I also want to make sure too, so before Joanne goes, I want to make sure too that we note that this is in the learning process. So we are going to formatively assess. But keep in mind, this isn't like, we didn't give this task to you with the intention of evaluating it. So keep that in mind as well. This is very early in the learning, we'll say, journey for this idea. And right now we're starting the consolidation to make sure students are sort of seeing some of these connections. So
it sounds like what Faye's actually got some good feedback to give the student when she sees this solution on the whiteboard or wherever. She could say, hey, give me some words here. Give me, fill me in. Now, Joanne's bravely raised her hand. And so let's call upon her to see what she has to add to this discussion.
Yeah, go ahead there.
Okay, I did mine differently, but I'm not going to talk about that because you have that picture. When I look at those 5 blocks, like the fractions is almost confusing because we are trying to think of 100%, right? We're trying to think of the whole thing. So when we talk about 1.5 or, when we talk about 3 halves or 2 halves, 2 halves, a whole. It like there's probably some confusion because of that, I would think, with students. I know there probably would be with a lot of adults too, quite frankly.
Actually, you know what? And that's definitely fair. That may or may not have been an issue in the class, but if there was, what we would then do is, remember, we're not just picking one student's work. We're going to go and we're going to pick other students' work as well. And we're going to try to make connections. So I wonder, does this visual help make that connection to the whole? Now, for some people like Joanne, you might look at that and go, okay, so I can see the whole and I see Sonia represents 3/5. For some students, that might still not be enough because they're like, well, where's 100%? Why is it split into 5? You might have to also show 6 out of 10 filled out for that, right? So yeah, for us as the facilitator, that's the selecting and sequencing. So based on the conversation in our classroom, we have to kind of be nimble on our feet to go like, a lot of students are really struggling with this representation. Maybe I'm going to have to find another way we can make a connection. And in my mind, I do have a couple up our sleeve to share with you. But definitely a great point and a valid point there, Joanne, that we want to make sure that, you know, as we go around the room, if we're noticing some students are kind of like spinning their wheels a little bit and they're like, I'm not seeing my thinking in that, we want to help make those connections. So that's a really great point.
Mm-hmm. For sure. Okay, each block there is 1/5.
Mm-hmm.
Yeah, and I would argue, I might ask the students, how do you see this being the same or different as that, right? And some things I might want them to notice is that over here, we have the whole represented and the 3 represent these 3 right here. And over here, we see the whole, and we're showing the other 2 blocks representing Eli's. There's those 2 blocks. So you can kind of see that connection as well.
Mm-hmm.
Something else, I saw another really cool, interesting one I want to pull up here as well. Here it is. Uh-oh, I'm at the end of my list. We had some really cool ones. We can't, and we always tell students as well, we can't go into all of them. So it's not, doesn't mean that it wasn't great if yours wasn't selected to share. It's just that based on today's consolidation, we might not get there. I'm wondering if you were to take a look at this, what if you see a student do this in the class? What questions do you have for this student? And after you share out, maybe this particular person might be brave enough to add a comment here, but take a moment to have a look. I'm gonna get my face out of the way here and let us know, like, how may this student have started this journey?
Very interesting. Yeah, throw it in the chat if you could see how they might have started this journey.
Mm-hmm. And I'll address, Faye has another question about reading a student's questions regarding organization. And this is a great question. It came up, I did a book talk, or I'm doing a book talk with my district on Peter Lildahal's book, Building Thinking Classrooms. And, you know, this comes up in that book. And again, this is part of the problem solving process, which of course we want to try to help students with organization, but we certainly don't want to hinder them having the willingness to share if their solution isn't organized yet. Because again, like math class should be kind of like the rough draft, right? Like a rough draft of anything we do. We don't want it to come out perfect because that would suggest that they were just copying off of something, right? We want them to actually be trying to work through these problems, much like we work through any problem in life. It usually starts off kind of messy. And then as we work our way through the learning, we start to help them with the structure. And we start to have certain expectations, certain you know, things that we want to see from students and expect to see from students, but definitely not early in the process, that's for sure.
Julie put it in the chat here on this particular problem where we were asking you to kind of see what happened, what might this student have done, what might this student have started with. She's put on that, and Anne-Marie has kind of chimed in where the 20% might come from on the idea of like, well, if you got 40, you know, Sonia had 60% of the vote, well, that means, you know, he had 40% of the vote. Well, she's got 20% extra, you know, there's 20% extra there. So 20% represents the 24. And then there's like an additive, there's like this additive thinking happening here where it's like, well, if I go 20% and if I add another 20%, or if I double that 20%, then I have doubled my 24 to 48, and then counting up in equal increments.
Yeah, and it looks
but also
like
you see this multiplying by 3. And then
I was just going to say, it's like there is some multiplicative thinking there.
For sure. It's like
so
both.
there probably is like some flexibility, right? Kind of going between those two types of thinking. But to me right there, it's like, wow, think of the connections. We did a session on fractions, decimals, percents, and now we're into proportional relationships. And wait a second, a percentage is a proportional relationship. Mm-hmm. Fractions have proportional relationships, like like they're innate, like they're there, they're ready to go. Super, super cool. And again, like phase on like the fact that they haven't, shared their thinking. Again, not submitting this. We're going to ask the students to verbally share that. That's why we're kind of doing this consolidation. So again, we're not looking for level 4 sort of submission answers here. This is the learning process.
Yeah. So if you think about, if you're running this lesson in your class, okay, so like we're running it here with you guys, if I was doing this digitally like we are here with you, we would encourage the student to turn on their mic and say, hey, explain this to us, or in the chat. If we're doing this in live in my classroom, I'm walking around, I'm seeing this on the wall, and then I'm having a conversation about thinking, right? I'm trying to gauge what students are thinking. I want to push their thinking forward. So I want to understand where this thinking comes from, and then we can talk about what to do next.
And I want to, you beat me to it there, Joanne. We did, like, I'm going to argue, first of all, we did this thing in Ontario, and we talked about this in our district. I did a PD session a little while back, and we had pictures, numbers, words was like the thing you had to do for EQAO. And the reality is, if you actually look at EQAO exemplars, which again, EQAO isn't the ministry, they are different things, different entities. So that's also important. But if you look at exemplars, you do not have to have pictures, numbers, and words to get a level 4, let's say. You have to clearly articulate or show your thinking. And I'm going to push back and argue that we haven't even heard from this particular student, but I can almost envision exactly how this went down. I still want to ask that student. I'm going to ask that student because I'm curious and I want to make sure my thinking's correct. But if this was an assessment even, I would argue that this model and how clear this student is, the one thing I might, and I would have that in the question, as I might ask, explain the process after, that might be part of it. But right here, like, I'm very, very impressed with where we're at. So we have to also, we have to just, I guess, have this balance idea in our mind, is that are some of the things we demand of our students, are they necessary all the time? Are they necessary sometimes? Are they ever necessary? And do they potentially hinder or promote students from taking risks in our class? So I know, like, John, in your class, like, you would be an advocate for, like, I want you to get something down. And even if you have to talk to me about it after, like, I want to make sure that that work is happening. I don't want to possibly hinder a student from trying or shutting down because they're like, I'm not going to get it perfect. Right.
Yeah. And I think when you asking students to write solutions, either on a piece of paper or a test or a quiz or on the board, or just to share thinking and you present it to someone else, you always want to encourage them to write it as if someone is analyzing that and could understand it from looking at it. Like, how did you get your answer? Can I see how you have done that? Like, that's showing your thinking. And so sometimes that doesn't always include words, right? So it can include pictures, diagrams, and say calculations even are quite fine. Like when you get into as a high school teacher, Kyle, if I went and asked a whole bunch of high school teachers if they had them explain in words how they solve problems, most high school teachers are showing procedural based algebra, and that is it. And I think when I'm encouraging my students, I want to see that thinking so that I can understand. That's it. Like, that's everything that we do is an assessment, is based in assessment, and using that assessment to push kids learning forward. And all I want to do is be able to see where's your thinking at so that I can push it forward if needed. And then we can have a conversation. That's everything that we do going forward is built on that.
Absolutely. Well, my friends, we've got something really, really cool here, because like now I want to give you kind of a heads up, and I want to share what I might do in my class. So first of all, John and I would have taken student work. We want to build on it, but we want to make sure, like, what's the learning goal? Like, what are we hoping they walk away with here? And for me, I want them here, like if we're talking about proportional relationships and solving equations, when I look at this, and I might also have, if it was in person, I would actually physically have these cubes. And I'm wondering in the chat, like, can everyone see, or can everyone tell me what do you think one of these cubes represents? And then what do you think, like, you know, the top row represents and the bottom row represents. Just go ahead and like toss that in there. What are you thinking? And John, just as they come, just kind of fire them out.
Julie, Joanne, both say 10% right away. And you know, Annabelle adds like there's that comparison. It's like Joanne and Julie wrote percent, but then we have Lisa and Annabelle writing their 12 votes. So it's like there's that comparison happening right there. So we've got Faye saying like 2/6 I think maybe referring to the red ones there. Cubes are 12 and the red is 24. So super that's cool. It's a nice way to break it down too, right? So if you've broken it down in terms of 10%, and you know that those two are 24, you can easily see that 10% is 12. Hey, if 10% is 12, how many votes are there, folks? It's a nice model. Yeah,
so you can kind of look at this, you kind of compare it, like if Sonia's on the left and Eli's on the right, we can see this like 60-40ness that some people were saying in the chat, or the 6-4, or this 3-2ness you can see there, or the 2-3ness. And, you know, we can highlight the extra with the red there. So something I want to highlight here, though, that this is really tricky for students. And like I said, in that grade 10 academic class, who had already been doing all kinds of solving equations and so forth, if I look here and I think about this, if I know that Sonia had 60% of the total votes, and I know, like, so I can see that on the left side. I'm sure everyone would agree, like, yes, that's 60%. So that is like 6/10 of the total votes. What I would articulate, or what I would push my students to articulate, and I'm going to challenge you, how would you describe on the right using some similar language? Like, what percentage of the total votes are on the right? And like, what do the red represent? Like, what might we represent that with here? What are your thoughts? What are you thinking? Any thoughts on that? I'm going to go ahead and say, like, and this is challenging, and it's extremely challenging for students too. This would be something that we push our students to try. I would argue that in grade 8, students are asked to explore some of this, but I don't think we spend enough time on it. And then it's a struggle in grade 9 as well. It's a struggle in grade 10. But when I look at this and I go, wait a second, 60% of the total is the same thing. It's equivalent to 40% of the total plus an additional 24 votes. Now, if you're seeing that in the chat, let us know. Give us a yes or a heck yes, something like that. Like, are you seeing that there's like 6/10 of the total votes on the left? On the right, we have 4/10 of the total votes plus the additional 24 to make them equivalent. Whoa. What are you hearing there, John? That.
I'm hearing I'm hearing your kids bouncing up and down in your house. But what I'm seeing here is a lot of yeses. Okay. So
a lot of yeses. Okay. I want to make sure. Everybody's with the chat.
Everybody's
all
with
right.
you here.
Now let's think about this. If I was like, actually, I'm a student, I'm like, okay, how might I solve this algebraically? So this is where we're trying to like push the thinking a little bit. Nobody here solved it with a equation, but we've created an equation and we've put them together. We've set them equivalent and we've said, okay, let's go ahead and let's try to solve this thing. So first off, if I was to look at that 24, like imagine if I just took 24 votes off each side, or maybe I was to take off maybe 40% off each side. Like imagine I remove 40% from either side. How many cubes am I going to get rid of there on each side?
4.
I'm going to lose 4, right? So I'm going to just get rid of that. And like, let's see where we're at. Well, now I'm left with 20% and that's 24 votes. And that was right in the solutions that our students saw. Our students today are you friends who are learning with us, but like we saw that thinking, we saw it here.
I think,
we saw it here.
Yeah, we got lots of people who I think saw that right away versus say setting up an equation to solve it. And that was what you were referring to right at the beginning when you were walked in with to this grade 10 class who was trying to solve this with a system of equations. You're looking at the equation, the equality between two systems of equations right here. So you can see like why they might want to think that they have to set it up that way. However, most of you already solved that equation mostly by just looking at that difference in the model.
Yeah, just concretely here today, it was
Yeah.
visually for most people, right? Some people did it through their proportional reasoning skills, right? Like setting up a proportion and all of that wonderful stuff. But what we're trying to kind of show you is that, you know what, this idea has legs and it keeps going. And then we get to some places where we do this abstractly, but we don't want to like allow students to forget where we're at. And then from here, if we go to solve it, we're like, well, there's 2 cubes. It's almost like you can see that 1 cube is going to be 12. Some kids might say, well, like if I doubled it, like that's going to be 40%.
Mm-hmm.
And if I double 24, that's going to be, there's that proportional relationship coming back, right? Remember that ratio table. It's like, oh my gosh, we're treating our equation like a ratio table here. And then I keep going. I'm like, well, maybe I could like, I don't know.
I was wondering, Kyle, sorry, you were blocking the 24. So it looked like there we go. I was like, something's missing off your slide.
There it is. Yeah, this is new for us. We don't know how to do this right. So, you can see this and like you can continue this doubling idea and look at that. Like you could see like, oh, I could go from 40% to 80%. Well, I mean, that's going to be 96. And you know what? Maybe I add on another 20% and I add on another 24. Now, I'm not expecting students in my classroom to do this. This is what I wanted to like show them that what they did is this. This is just the symbolic version of it, right? Some students might be like, wow, that seems like a lot of work. Can't I just go from here and like, I know 20%, there's 5 20s and 100. Yeah, go for it. Rock and roll. Like, multiply both by 5 and you're going to get there. But at the end of the day, we want students to be able to take this thinking and be able to extend it from concrete and the visual and connect it to the symbolic so that they can see, holy smokes, even abstract math can be solved in a non-abstract way. It can be represented visually or concretely. And if I can see across these different representations, then I'm really showing a proficiency with the mathematics.
Mm-hmm. And I really like that you point this out because of two specific reasons, and it's more vertical as reasons as if you're looking at this solution. High school teachers would say start with this abstract representation and just go straight there. When this is why students in high school are like, I'm a little bit lost. I'm not sure what's going on because that abstractness is so clear in high school. Whereas then if you went, but if you start with models, like we have many teachers that say we're going to use models down in elementary school, but not in high school. But if you're using models in elementary school, and we can get those models to trickle forward, and students bring that knowledge with them, and we have our teachers who are at the high school level going, we should be using models as much as we can, then we're starting to make these great vertical connections in our math. And I know, and the other thing I wanted to bring up, Kyle, here was that the idea here is that this is something you might use to teach this like system of equations in this way to model this solution. But by giving students the chance to model it and show models like we did with you guys, you as a teacher now get to connect, and Kyle did just say this, but connect the models that you used to this solution, which kind of brings that modeling solution into the algebra world. And normally that's not done. So I think it's great that this verticalness happens from elementary through to high school, but also this use of models this use of like allowing students to come up with strategies and solutions, and then you tie them all together by showing what you want. You say later on, like, I'm going to show you this strategy. That's really what you guys did, but in a more kind of streamlined or abstract way.
Yeah, absolutely. And I see in the chat, some people are saying, it sounds like I must model during these sessions. And you'll note
Yeah.
we try to get people modeling just because, like, again, if I can only see it one way, and for me, that would have been symbolic for quite some time. If I could only see it symbolically, how do I meet my learners where they are? Somebody else said, this is amazing for visual learners. I want to add on to that comment and say, this isn't just for visual learners. This is for students to become proficient mathematically, because if I can only see it one way, you will run into bumps along the way where you need to be able to conceptualize it. And, it isn't a one-way street. Like, I want students to be able to prove to me why they know what they know, and that they didn't just multiply, divide, and, do all kinds of operations. So this particular task, it's one that I love. Again, we want to reiterate that when we do these tasks, John and I are geeks. As you know, we're playing with new software tonight to try to make these more interesting. That's not something that actually it's not the game changer for you. So first of all, we have a bunch of tasks that you can use. I really don't think you should spend your time creating these tasks. I know John would agree, unless you're just a geek like us and you like doing that on your spare time. Use your prep time to think about, what is it I'm trying to emerge in my lessons? And then also, like, how could I do something with a regular word problem from my textbook or that I usually use? How can I change it so it's a little more engaging? It doesn't have to be a video. I could have brought this coffee canister in and placed these pieces of paper on the table live with my class, or I could have done this live with you. I wouldn't have obviously counted them in front of you, but you would get the same idea. And a lot of people get hung up in this idea of like, oh, I need to have a video in order for this to be engaging. I want to let you know, like, this is where this problem came from. It came from the University of Waterloo Problem of the Week. So many students across the province and maybe beyond have probably attempted this particular problem, but in a very different way. Now, we're not suggesting kids should never use word problems. We want to scaffold them there, but early in the process, we want to get them engaged. We want to make sure that they know that they can solve these problems, because every student's a mathematician. So
that's good to point out, Kyle. And it's so good to point out too that anyone can take say this word problem that was there, or this application problem that you can find in all of your textbooks or all of your resources that you have at your disposal, and kind of modify them to fit your class, but also be engaging, and you can follow that curiosity path. Where notice that we dragged out, like Kyle said, it didn't have to be the video, but the beginning part of this task was very dragged out to bring in the engagement level, and bring in estimation, bring in the number sense and the numeracy. And then remember that we allowed students to showcase thinking on a problem before we kind of consolidated that thinking. Most of the time, and I taught this way for so many years, is I did the reverse, right? I would skip estimation all the time, because I'm like, we'll just get to the number. And then I would show them how to do it. And then I'd say, now go practice it, instead of flipping that around. So we want to make that part very clear, that you don't have to have the video, but you can use any kind of task, but slowly drag that out. And one way, part of the curiosity path that we haven't really dove into, like, the elements of the curiosity path too much, other than I think in our first episode, which was a video about like withhold as much information as you can to generate that curiosity. Kyle, why don't you tell them how to modify this task for their grades, and then we'll wrap up.
Yeah, like I had this one up on the screen, so I won't spend too much time. But if you're in primary and you're just adding and subtracting, again, like you could use some of these contexts, and we're not going to give them words. You could just verbally share this with students, right? Verbally share it and explain this is the scenario. So you still could use some of the beginning of the video or any of that stuff. If I'm moving up a little bit, we could talk about, let's say you want a trip to the park received 3/4 of the vote, while, so this is before percentages. While the trip to the library received 1/4 of the vote. If the park received 10 more votes than the library, how many students voted? This problem right here is still super rich, because it's actually leveraging the same thinking, but now we've gotten rid of percentages, and now we're dealing with much more manageable fractions, right? 3/4 to 1/4, you'll notice that we're just trying to nudge them along. Or maybe, you like something a little bit more like this. So don't be afraid to modify for your grade. The one thing that I do, and John and I do advocate though, is that you don't want to modify down all the time, because sometimes you actually take the richness out. So, challenge your students, but think about where they are and what learning objective you have. So hopefully this has been helpful. John, as John mentioned, the curiosity path is something that, we try to incorporate into everything we do, including teacher PD sessions. You'll notice we work hard to keep you engaged. Remember, students are there because they have to. So we want to try to find ways that we can get them engaged in the mathematics, but not in a gimmicky sort of way. So I hope you see that it was rich math. We were fueling sense making today, and we're really trying to ignite your teacher moves so that you can do some pretty awesome stuff in your math class. So John, what do you say we wrap things up, and why don't we let's hold ourselves accountable? What do you say?
We got to go bring back the what you'll get. So give us a yes in the chat, like we've done in all of our sessions. Did we help spark curiosity through the curiosity path? Did we kind of try to engage our learners to kind of get them into the math instead of just giving them examples and procedures? Let's give us a yes if we went that way today.
Yeah, is anyone saying yes there?
Yeah, they're all in there, Kyle.
They're all in. Awesome. How many people are feeling a little bit better about proportional relationships? Today, we were exploring proportional relationships in a slightly different way. We were kind of playing with equations as well near the end, but this idea that fractions, decimals, percentages, they're all proportional relationships, and that we can actually use these relationships and we can reason with them both visually, conceptually, and abstractly with symbols as well. How's the heck yeses going? Are they're coming?
They're all in there. Lisa just said this was so rich, and I really appreciate, Kyle, that you kind of showed that you can model proportional relationships instead of just showing setting up a proportion of fractions and going, I'm going to cross multiply. So that
which still works, works, but I want to make sure we understand it, right?
Right, exactly. And this last one, that is the one that we've been doing the whole way through in all of our sessions, and will continue to do in the next 4 sessions after this one. We want to help you repair the relationship you have with mathematics. We want to strengthen your relationship with it so that you can help your own kids and your students in your class do the same thing, because there's so many people are coming out of school, thinking back, reflecting back on their math experience and saying, I'm so glad I'm done math, or I hated math, or math class was terrible. And I'll be the first to admit it's probably high school they're remembering, but we want to do this in all of the grades. And this is something that I'm trying to do in all of my high school classes too. So we want to repair that for us so that we can repair it for them.
Fantastic. And I think the last thing, John, we've got that online workshop open right now. Tons of people diving in. So we need to have your big takeaway shared out in the chat. So take a moment, go ahead and do your big takeaway, and we will select someone in a couple minutes.
We should talk about it, just because there's some new people here, but
that's true.
So last week we gave out a free seat into this workshop. We've got a workshop running right now. And in past, we've had 1,000 teachers through this workshop. Kyle and I do this, in the evenings, on the weekends. We've built this workshop. It took 1.5 years of building this out, which is we teach everything that we've been talking about, the curiosity path, and how to put all these ideas together in your classroom for lessons. We have, what do you do beforehand? What do we do in the middle? What do we do at the end? How does it fit in long-term planning? How do you actually do engagement? We have a whole module on engagement and the tasks and the little activities we use to go into that. We only kind of touched on a couple things here tonight. So this course runs from now until the end of April. It's kind of it's not a live situation, kind of like we are doing now. It's an asynchronous kind of model where you have access to these modules and these lessons, and then you can work through them at your own pace. We gave one free seat away last week, and I believe that was with Kay, I think. And Kay already registered. She's in. She's probably started already. I'm not even sure if Kay is here tonight. I didn't look for her name, but we want to do that one more time, Kyle. We want to ask you to put your big takeaway in. Kyle already asked you to do that. We're going to choose from that list. So we just scroll and we pick one random big takeaway, and that person is going to join us in this cohort of the Making Math Moments That Matter online workshop. So get your big takeaway in, and we will randomly pick one of those from the chat.
Yeah, why don't we hand it over to Michel, and then as soon as he's done, we'll pick that winner.
Actually, let's Michel pick. Ooh. That's what I thought you meant.
Oh, we can do that too, but let's turn it over to him so he could wrap it up while those comments are coming in, and then we'll pick it up.
Okay, guys, if you let me pick up someone, I have picked up someone already.
All right.
Oh,
yeah,
beautiful.
I did.
You saw a good comment.
I'm going to be a bit biased, but I picked up someone already, so I'm going to say.
All right.
First, I must say the presentation was fantastic, and you guys always come up with new things. I wonder what you're going to come up with next time. But early in the presentation, when you started the voting exercise, and you asked who was coming, who was winning the ballot. Actually, there was a very funny response by Marcus, and Marcus said that Trump thought he had, or Trump said that he had. And I think that Marcus, it was very funny. It really made me laugh, and I think that I think we can give it to Marcus.
All right, and Marcus's big takeaway was the need to have multiple ways to demonstrate proportional reasoning to his students. My way is the only one way. That's good, Marcus. I'm glad that we brought that up.
Obviously,
so, Marcus, go ahead, Michel.
No. I just say, obviously, Marcus is a very creative mind, and yeah, we are happy to give it to him.
All right. So, Marcus, what you need to do is, I think, Kyle, did you put the email in? No. Yeah. Okay. So I'm going to put our email in the chat. And Marcus, all you got to do is email us and say, hey, I'm Marcus from the OTF webinar today, and we will send you free access on how to get into the online workshop. You can visit that link at the bottom to learn more about it. But here comes the email.
Awesome. Fantastic. Well, thanks so much, everyone. Let's hand it on over to Michel. Thank you, sir, for being an awesome host as usual. We can't wait to hang out with you next week.
Yeah, so just 2 minutes to finish everything. I'm going to share my screen again. Just a second, guys. Let me share my screen. I'm going to do my usual blurb. Thank you guys really for this fabulous session. I also want to thank all the participants, especially Michelle. I don't know if she's still in the room. Yeah, Michelle is still in the room because I like the way she picks up anytime there's a mistake. She's really astute. She's a real teacher. She picks that up quickly. And also Joanne, of course, because Joanne, I don't know if she's still in the room, but she was very courageous. She came in, she turned her mic on. And so I just want to thank everybody. Tomorrow, you're going to receive a follow-up email. There will be a little questionnaire. Please take a few minutes to fill it up for us. And you will also have access to all our resources. And I just want to let you know that this was session number 6. We still have 4 coming up. Every Thursday, we hope to see you at 4 o'clock for the next 4 weeks. And we're going to look at linear relationships and equation, analyzing data and probability, and then 2 sessions on measurements on January 28th and then February the 4th, the 11th and 18th. So I really, really hope that we're going to see you all. And I'm just going to put into the chat box. Where is my chat box? Where's my chat box? Here it is. I'm just going to put into the chat the links in case you don't want to wait until you receive the email tomorrow, but you will receive that email tomorrow. So that's it. Fantastic session. I just want to thank all of you. Thanks, Kyle. Thanks, John. Really beautiful as always. And I'll see you all next Thursday.
Thanks, Michel. Take care, everyone.
Thanks, everybody. Talk to you soon.
Thanks so much for your participation.